So I'm Jason Douglas. I'm a lead product manager for Knowledge Graph and the Knowledge Graph platform, and joined today by Dan Brickley, who's a developer advocate for Knowledge, which I think is a very deep title if you think about it. But more specifically, that is about improving the state of structured data on the web through things like Schema.org and other standards. So I want to accomplish a couple of things here today. One is to give you sort of an overview of how search is changing and how Knowledge Graph is sort of behind a lot of those changes, and how that's really increasing the importance of structured data and just understanding on the web and what that means for everyone here. And then Dan's going to get into a little bit more details about what that means specifically technically in terms of Schema.org and markup standards and the evolving tool set to support that. And then getting into a little bit, we're still in kind of the early stages here. And there's a lot of exciting stuff that's just starting to happen. Well, I think will continue to evolve. Also, part of the goal is to give you a bit of an overview. Like I said, provide some context here, because there are several sessions later in the day that will actually dive down deeper on some of the topics we'll touch on, and we'll try and highlight that as we go when there is another session that will give even more detail on something. Okay. So if you caught, I'm assuming most of the people caught the keynote yesterday. I know it was pretty crowded, get sort of a general sense. But Amit was saying that search is changing dramatically right before our eyes, which if you think about it is a pretty big deal. I mean, this is our flagship product used by billions of people, and yet we're saying it's changing really fundamentally. So why would it be changing really fundamentally? Well, because the nature of the internet and information in our lives is changing very fundamentally. In the last few years, all gotten smartphones, internet connected, more and more devices are connected, and information is not just this sort of research task that's done at a desktop, typing in queries. It's part of your life, right? It's on the go. It's information as you need it, when you need it. And just what you need. And so search needs to evolve to meet that world and to meet those needs, and I believe we are. And so some of the key things that search is doing now to fit in this world, to be that sort of seamless assistant. I think he used the analogy of the Star Trek computer. As something that is available when you need it to answer questions. So just simple things like, what's playing at the Metreon across the street, or when you're sitting down for lunch, how many calories are in the cheeseburger that you're about to eat, or just things that you need to know. But also being able to then follow up. And whenever you learn something, it sort of brings new questions, like, well, how does that compare to a burrito, or what time are those movies showing, or these kinds of things that actually require some context of what's going on, or even when is my flight late for getting home, and knowing that as an assistant would, what flight you were on, what flight you had tickets for. And then even anticipate. So if that flight is going to be late, letting you know, because of course you would want to know that. Or that it's time to actually catch the cab if you're going to get there in time. So in order to enable all these kinds of things, the thing that's really that a personal assistant would have is really an understanding of the real world, is a memory of what are the important things to know, or what is the context that we all share. And again, that context really is the real world. So we're sitting here In Moscone today, which is in San Francisco, and there's a bunch of things nearby. There's, I mentioned the Metreon for movies, and there's the museum, and tourist attractions, all these things. These are things that we generally know or are very knowable things about the real world. And the more of these things you know, the easier it is to answer questions, have conversations, and like I said, even anticipate needs. So the fundamental thing that's changing in search to bring this about is, well, how do you have an understanding of the world? And one of the first things is you have to actually be able to think about things as things. And traditionally, search has been very much about strings. So if you think about the content on the web, the text in documents, those are words. But there's some funny tricks that words can play. And so I think when you see this picture, I assume most people in the room immediately recognize this gentleman. But he's gone by obviously very different names, or many different names over the year, almost sort of amusingly so. And yet, I think most people don't get too confused about who that is. But if all you're thinking about is strings, is words, then it's actually can be quite confusing. And so if you even just think about sort of your own systems, how do you keep track of these things? Well, generally, if you want to be able to deal with name changes in a database, you give it an ID, and you make the name just an attribute of that thing. And I think if you sort of think about what the backing database to most websites, a lot of people do that for the important things in their systems. But usually at some level as you go down, you think about the attributes of one of these entities that at some point becomes a text string. Like, the location of where somebody is now it's a city name. It doesn't have an ID or whatever it may be. At some point it becomes just strings. And so that's kind of the crazy thing, being Google, that we've taken on, which is to actually keep going and to give everything in the world an ID and try and sort of model all the connections and relationships between all the things in the world. And this is what we call knowledge graph. So I'm going to talk about how knowledge graph gets exposed as features, as a platform, et cetera, but at its core, really what we're doing is creating some model of the world so that we have the context that we all have about the real world and can do things like answer questions and converse and just, like I say, have a model of the world. Another thing about, in addition to thinking about things as, the real world stuff as abstract entities. With a graph data model, we also can more easily take on new facts about the world and create new connections between things. And I think this is a lot like the way people think about the world. So, as we said, when Snoop comes up with a new name or something else changes about the world, it's actually pretty easy to adjust our understanding, much easier than it might be otherwise. So what is some of these things useful for, as I was saying? That one of the things that knowledge graph can help us do is answer very factual questions like how long is the 101. I don't know if people have had the pleasure of driving on 101, but that is, even if you're only doing a section of it, it kind of feels that long. But even more importantly, there's some subtle things about having this catalog of real world things, knowing what things exist, actually help us better focus in on what somebody might be looking for or help a user. So if you type something ambiguous, like giants, there's a lot of things in the world that are called giants. There's multiple sports teams. There's the mythological creature of giant. In this case, in San Francisco. I'm interested in seeing if there actually is a Giants game. But it becomes very clear, rather than having to sort of hunt through results quite as much, I can see that, no, San Francisco Giants is what I'm really interested in on the right there. And if I click on that, it automatically refines the query to San Francisco Giants, and you start to get very relevant information and results about the San Francisco Giants. So one is that they actually are out of town right now, but you see when the next game is. And a bunch of information that we have in Knowledge Graph about the Giants, who the manager is, the roster, and even where they play, which is fairly nearby, AT&T Park. And so you can even click through and refine to that and see information about AT&T Park, where it is, click through the map to actually get directions there. But we can even go a step further. So we've sort of summarized these things, expose some of the connections between the real world things, but also it can sort of help discover things that when people are searching for AT&T Park, they may be interested in sort of the other sports venues around town, or they might just be a tourist and wanting to see other tourist attractions. So often when people are searching for AT&T Park, they're also looking at things. If you look, it's kind of hard to see at the bottom there, but things like the Ferry Building or Fisherman's Wharf or Union Square or all the well-known tourist attractions. So one thing from a developer perspective, before we're going to move on to structured markup and the web as a whole, but I did want to sort of take an aside for a minute and make it clear that actually the knowledge graph itself is available to developers. So any information that we learn about the world that comes to us from openly licensed sources so that we actually can redistribute it or share it with the world is available with Freebase and the Freebase APIs, so developers.google.com/Freebase. And that's a lot of stuff. So 40 million entities and a billion facts covers a lot of knowledge of the world, which is very useful. So it can be used as, if you don't have the time to give IDs to all the things of a certain kind, you can use Freebase as a catalog for those things. And there's lots of APIs and services for being able to match your data, for being able to do entity autocomplete for lookup, get facts about an entity, all kinds of stuff. So if you're interested in that, there's 2 sessions. There's one session later today on search and suggest with the Freebase API. And then there's also a workshop, a hands-on thing that I think sounds like it's going to be pretty cool tomorrow that also involves YouTube. So I don't remember the exact times for either of these things, but I'll have schedules. OK. So far I've been talking entirely about the knowledge graph and how that's changing search. But this is all based on just this abstract model of the real world. What about the web and how the content and information from the web connects to all of this? So I wanted to actually start to show some stuff here. Let's see. So how many people here are familiar with rich snippets? Is this something that's sort of fairly, okay, yeah? It's about a third. All right, so maybe I'll start even a little earlier. So there has been a feature. So let's look at, I was talking about the Star Trek computer earlier, and there happens to be a new Star Trek movie. So there has been the ability for a while in search that given some structured understanding of a page, that we could enhance the snippet. So normally a snippet in search results is some section of the page that Google believes is relevant to the query. But sometimes you can have sort of enhanced presentation of that, like if we really know that there's ratings or reviews, for example, or events or information about a movie, those sorts of things can give a more structured result that makes it a little bit more obvious about what's on the page, what it's about, to sort of help the user choose the right result. But with Knowledge Graph, we can go a step further, which is that it's not just that this is structured information from that page. It's actually clear that that's about the movie Star Trek Into the Darkness, or Into Darkness. And so whenever we're displaying information about that movie in whatever context the user might be, we actually know that it is associated with it and can highlight it. So when I see the Star Trek Into Darkness knowledge panel, can see the review scores, and I'm like, oh, that's pretty darn good. I tend to focus on the outliers, the negative, when I'm trying to figure these things out. So then I can very quickly, from the movie, get right to the most negative thing said about it and make my decision based on there. Some people might like to do it the other way around. But. Okay. So that's one example of associating the existing structured data on the web sort of to entities, sort of in that same context, but that's not all that was sort of already on the page. But we can go sort of a step further. So say a friend of mine mentions that they're going to a Mumford & Sons concert. And I'm like, I don't even remember, like I didn't know there was one, where is it, when is it, that sort of thing. If I even just search for the band, been able to not just have information about these facts about who's in the band and what are their songs and that sort of thing, but from the web, being able to learn that basically what are their upcoming events, what are those concerts, and I can see, well, in fact, it's next week in Berkeley. But I think the kind of key thing here is I didn't know when and where it was, but now it was very easy to find, and if I click on it, I get a very focused experience about that specific thing. And so I immediately see, okay, it's at the Greek, and if I want to buy tickets, it's right there. I can find out more about the venue. I can click through to actually buy tickets, and got to that sort of result very quickly, even though I only just knew that it was Mumford & Sons. I didn't have to figure out how to find that specific event or where it was. Let's see. So these are some very early features about how structured information and content from the web can connect to Knowledge Graph. Like I said, I think we're at the very, very beginning. This was leveraging the stuff that already existed from rich snippets. There's so much more that I think can happen, and we'll get into some of the new features towards the end of the talk. But I think the key thing is that if search is really starting to think about things in terms of the real world and these entities and how they all relate, it's going to be important to actually understand websites and your content in that same way in order to be able to surface it in the seamless way that users are now expecting. When you're talking about answering questions over voice on mobile or via glass or whatever, that it needs to be as seamless as possible, and it takes that level of understanding to be able to surface it for users at the right time. So with that, I was actually going to hand it over to Dan to actually get into the meat of this is all the sort of vision kind of stuff and the context for this, but want to get into specific of like, well, how does this happen and where is it going?
So I think that's a great slide because it shows on the right-hand side the world of Schema.org, and on the left, the world of the knowledge graph. And I love Freebase, I love the knowledge graph. I carry around a lucky copy of Freebase on my data stick. The web is a lot bigger than Freebase, and it's a lot messier. So I'm going to be talking mostly today about structured data in the context of Schema.org. And Schema.org is for the rest of the web, for that big sprawling chaos. I'll start with a bit about the project, about its origins and partners, and the community we're building out at W3C. I'll also walk you through a bit of markup, just to show you how simple it can be. And bit of the data model that sits behind it. And you've already seen the data model already. It's graphs, it's attribute value pairs. Finally, I'll say a few more words about how Schema.org fits with a knowledge graph and give a quick look at some of the tools we're building out to make your structured data lives easier. So that's the website. It's not the most exciting site in the world. It's patterned after sitemaps.org, which was another collaboration with partner search engines. So where did this come from? Why Schema.org? Well, to describe real-world things in a structured way that you can understand, others can understand, you need some vocabulary. And then the question is, which vocabulary? A couple of years ago, Avi Guha from Google had the insight that search engines really should be cooperating on these vocabularies rather than competing, and that by doing so, webmasters' lives, developers' lives, publishers' lives would be a lot easier, and that this would broaden the adoption and utility of structured data on the web. So Guha got talking with teams over at Bing and Microsoft and at Yahoo, and they were thinking similarly. So from those conversations emerged Schema.org. Ta-da. So since that launch, we've seen quite impressive adoption, and we've been joined by, fairly early on in the project, by Yandex, and we're talking now with Baidu on how Schema.org can work better in China. So maybe you weren't expecting to see these company logos in a Google talk, but the thing is we're proud to be collaborating with these teams from Microsoft, from Yahoo, and from Yandex. That Schema.org, with its global ambitions to improve the whole web, just would not be possible without such partnerships. We think the collaboration's going well. We're happy, not sad. It's going well for the project and for the web as a whole. But it's not just these four organizations. This slide's not doing what it should do. Oh, there we go. So there's been a number of individuals, groups, organizations, companies have stepped forward to propose extensions to Schema.org since we launched. I'll run through a few of these here that we've already adopted, talk about some of the things in the pipeline. Pretty early on, we had the RNews group from IPTC propose a vocabulary for describing news articles. So that went in late 2011. We added late last year a language for e-commerce for describing offerings on the web. We've very recently added a language for describing data sets. I think you saw yesterday the statistics showing up in the front page of search. So that's, I think, a taster of what can be coming as it becomes easier and easier to get hold of data sets and to understand just enough about a data set, to integrate it, to cross-reference it, and to provide some user interface around it. So that's really exciting work, and that's picking up on work that was done at W3C in the Linked Data Working Group for Government. Another really exciting development, and again recent, was the LRMI, Learning Resource Metadata Initiative. So this is for describing open educational learning resources. That was co-led, I think, the Association of Educational Publishers and the Creative Commons. There's a whole pile of other groups. And this is a tricky problem. We've got one schema. We're trying to make it as simple as possible for all topics, for all domains, for anything that could be on a web page anywhere. No one really knows how to standardize these things. I used to work for W3C. I've seen web standards made for technologies, and the key there is to be super focused on one thing. Schema.org is super focused on the entire web. So we're making up the process as we go along. We've created a community at W3C. We've made it as open as possible. The 4 search engines have kind of stepped back and taken an oversight role. A handful of search engineers from 4 competing companies, they're not the right people to come up with descriptive vocabularies. But they do share the role of making sure these things kind of hang together. But I think going forward, W3C, the community around W3C, the open mailing list that we have, is the place to be. It's all linked from the Schema.org site. You're very welcome on the mailing list. And yeah, come along. So, schemas in practice. Before we jump into the markup, I wanted to just say a few words on the basic thinking, the conceptual model behind this. And it's not complex. The point of Schema.org is to serve essentially as a dictionary, listing kinds of things, kinds of properties for each type of thing that you might have a description of in a web page. So you see a fragment of the schemas here. Markup describing a creative work, I might mention, is an author, might mention the intended audience, the date it was created, and so on. The hierarchy is fairly flat. We don't try and model the world super formally. It's just a way to organize our properties. So for example, a video object description might use a video frame size property alongside a bitrate property by virtue of being a media object, or a genre, because all these things really are creative works of different kinds. Schema Dog is just this huge collection of properties organized by their association with these types. And so for each property, we say which types they make sense with. There'll be a list of properties that work with local business, with event, with blog, with exercise plan. Developers should recognize the data model immediately. Let's move on to markup. It's attribute value pairs, it's graphs, it's things related to other things. So this basic data model is decades old, but when we launched, we had to pick a more specific markup, exact computer structures to put into HTML. We launched using HTML5 microdata, which gives you a handful of attributes that mix into your markup. W3C's RDFA Lite is another very fine alternative. As far as Google is concerned, they both work. In either case, the conceptual model is the same. Things, properties, values, attribute value pairs. So how does this look in practice? So let's describe a couple of things. Keeping it simple, a movie and a person. If the movie was if the person was an actor in the movie. So this basic example gives us enough to understand how Schema.org works and three of the essential patterns that go into Schema.org markup. The examples are given in microdata syntax, by which I mean the words here, item scope, item type, item prop. RDFA would look very similar. These are not just toy examples. If you go to Rotten Tomatoes, Netflix, IMDb sites today, I think as you saw earlier, you'll see this markup live in the wild web. So here we see the simplest microdata example. We're effectively saying, there's a thing, it's a movie, and here's its name and here's its description. You can't get more unexciting than that. It's great as far as it goes, but how can we do more? How do we indicate the relationships between the things that we're describing in the web? What if we wanted to talk about, say, the actor Johnny Depp? What do we got here? Why would we want that relationship? I think structured data, it's so much more useful when it's connected into larger structures. Every new fact we learn about the actor indirectly teaches us just a little about the movie, and vice versa. So let's add an actor. This second paragraph here, you'll see we're adding a paragraph that says, in effect, and that movie has an actor relationship to a person with the name Johnny Depp. Schema.org's job is simply to be the collection of those terms, actor, person, name, and to grow and grow as people ask for new types of thing, new types of relationship. We can go a little bit further. Third scenario. Here we see the actor link points off to a whole page about the person. If we get back here, it's great describing Johnny Depp in line, but we can't say everything we want to say about Johnny in the page about the movie. So we start to break up our descriptions and spread them across the web. A little bit in the movie page, just enough to identify him, and then a hyperlink across to maybe a landing page on IMDb or somewhere. There we go. So ahref equals a pointer to the page about Johnny, and the relationship becomes a typed link. It says a bit more about the association between the movie and the person. All right, so you've seen now the three core patterns at the heart of Schema.org markup. There are attribute value pairs, where the value is A, something simple like the string, Johnny Depp. Simple. This is the oldest data model in the book. B, a thing, but you describe it in line with markup in the same page, more attribute value pairs, so kind of recursive. And C, the interesting one, is where you start to spread this across the web. So attribute value pairs, where the value itself is a thing, but the thing is described in more detail on a linked page somewhere. Hopefully a page that has further Schema.org markup. So Schema.org makes it possible to do useful things with the simplest of markup, but also to provide mechanisms that allow descriptions from multiple pages to be composed to larger and larger linked graphs of structured data. So we want to grow out this graph of data. We want to ensure that Google understands what your entities what entities your content and services are pertaining to. And to help Google and the other search engines understand this, we've recently proposed a new Schema.org property called same as. And same as means pretty much what you might expect. It's the same entity. So you can easily point to well-known pages for that same entity elsewhere on the web. So examples at Wikipedia or their new Wikidata project, Freebase that we heard about earlier, IMDb, these other well-known sites. Any of those pages can serve as a kind of proxy identifier for the thing they describe. With the same as markup, you can make your web pages unambiguous about, are you talking about Paris Hilton or Paris the city? If you want to use a bit of hidden markup, that's just fine. Slightly different bit of markup here. That's pretty much it for the markup examples. So I just wanted to try and put the modern graph data models in context a little. So the web of linked data idea is not a new idea. Schema.org, alongside the knowledge graph, has essentially the same graph-shaped data model as W3CRDF, for example. Wikipedia's Wikidata project also recently adopted this property-centric data model. The typed links idea is older than the web, but since the web itself recently celebrated 20 years as an open platform, I thought let's revisit the words from a page from 1992 on link types. This is one of the very first web pages recently restored to the web by CERN. I think Tim Berners-Lee probably wrote this. He said, some link types, for example, express relationships between the things described by two nodes. And that's it. That was there, probably the fifth or the sixth page on the web. This idea has been there in the web from the start. It's not a surprise it's been there in logic for centuries, but Schema.org's role is to be a provider of this vocabulary, particularly for relationship types. Many kinds of things are described in the web. We name our types as a way of organizing these relationship types. So place or organization might be associated with the contained in, founder, name. Some of these properties take strings, but a lot of them take things. And in a web context, things can be represented by relationships and by links. So at the heart of Schema.org, and at each Schema.org vocabulary, is this very old and foundational idea that it's useful to give names to properties that express relationships between the things described by two nodes in the web. So if that was there right from the start, right from day one of the web, why has it taken us so long? In less than 2 years of Schema.org rollout, we're seeing tons of this stuff out there. And I think what's become clear to us is that when publishers have a clear and growing incentive to add markup, up it goes. I don't have statistics handy, but there's a lot of it out there, spread well across the web. And the Alliance of Search Engines supporting Schema.org have given a huge boost to this way of thinking about data. It's actually useful now. Secondly, Schema.org did make some subtle design tweaks to make life easier for publishers and to aid mainstream adoption. So I'd like to expand on that last point briefly. We at Schema.org try and provide a unified documentation hub. The point of this is that we don't want busy developers, busy publishers having to rummage around the web, piecing together bits of vocabulary, something here for geography, something here for people, something here for places, each with perhaps a different data model or a different syntax. So we've taken on more of that work. We've worked hard to unify these different ways of describing things so that you just go to Schema.org, find a useful piece of vocabulary, and get on with your lives. We've tried to find a balance there, drawing together independent designs, but providing a consistent environment and a consistent data model for their widespread adoption. Now, I just wanted to say that our approach owes different things to different communities. From the linked data and from the semantic web community, there comes a concern for the graph data model and a concern for supporting decentralized descriptions. You shouldn't have everybody in the same room when you're creating a schema. You should have conventions that allow different groups to go away, come up with some list of types, list of properties, and a model that allows you to plug them all together. From the microformats community and the HTML5 community, we've taken a concern for simple, clear, and developer-friendly markup. And as a semantic web person, I think that's been huge. A lot of the semantic web work is amazing, but super hard for developers to get a handle on. So we're really trying to be simple, easy, and clear with the Schema.org site. So these conversations between different groups in the web community They're really easy, but I think they have led to stronger web standards. So W3C's RDFA Lite, that learned a lot from microdata. Microdata learned a lot. It was a redesign of RDFA 1, which in turn, microdata also drew upon microformats. So as far as Google's concerned, it's the graph that matters, the graph that we care about. We can get the graph from RDFA, from microdata, from JSON LD. Schema.org's approach lets us make parallel progress on syntaxes and on schemas. So every new and improved schema can be used immediately in any syntactic format you like. Some of the smart mail scenarios you've heard about this week are using JSON, for example. Doesn't matter to us, it's all a big graph. Maybe you prefer Drupal, XHTML, RDFA. Again, that's great, that's your choice, that's your website. Go crazy. The approach we've taken allows different sites to share common data vocabularies, even if they disagree on syntax. All right, so I'm just going to run quickly through some of the webmaster tools. There's a session following this one that goes into a lot more detail on these tools. Firstly, Schema.org itself. We've got time for clicking around? I think so. Sure. Let's go crazy. All right, don't get too excited. I'm going to show you a website. If you visit the Schema.org site, you'll find a very regular website, very structured. Essentially, there's a page for every type. There's a hierarchy. So if I go to the documentation section, let's try a larger font. The full type hierarchy. So basic data types. Thing. So in the Schema.org universe, everything is a thing. And the interesting work is saying, what are the subsets of thing? So creative work itself has subtypes: article, news article, scholarly article, medical scholarly article. We try not to go too deep, but these types give us attachment points for properties, and also in a social sense, attachment points for collaboration. So perhaps the medical collaboration focus on the medical scholarly article type. What else we got here? Code, so that came from the team at Microsoft. Data catalog from the recent datasets edition. It goes on. It's smaller than Freebase, it's smaller than Wikipedia, but it's hard to memorize. And it's got to the stage, let me give you an example. Place of worship. So I'm really happy that we're collaborating with the Wikidata project at Wikipedia. So if you look here at this example, place of worship is a civic structure, is a place. We listed at launch, I think, 6 types of places of worship. There are many, many more you could list. And this is one of the places where we say, stop, we can't do this. This is where Wikipedia comes in. And the collaboration with the Wikidata guys at Wikipedia is giving us a story for how Schema.org gets big, but it doesn't get too big. And then Wikipedia comes along, and the masses of thousands of Wikipedia community members can figure out, how many kinds of place of worship are there. We don't want to be doing that. We're a handful of search engineers collaborating while working for competing companies. We're not the right people to do this list. So that's been very important for us, figuring out where to stop and where to let others plug in. What else to show here? Get moving? All right, that's probably enough Schema.org. Did I close the browser? No. There we go. So the markup helper is a new tool. It helps you write markup. You put HTML in, you work with where are we? Interface on it, yeah. It helps you add this stuff without knowing the standards inside out. I don't know this tool super well, so I'm going to shut up now and point at these guys who will be speaking later. The testing tool I use every day. This used to be called the structured data testing. Used to be called the rich snippets testing tool. It's now the structured data testing tool. It shows you what Google thinks your page is saying. It also shows you what Google's custom search engine will make of your page, which is great because that's a tool that can make quite sophisticated use of structured data now. Thirdly, instead of thinking of your structured data page by page by page, we're starting to see tools. So in the webmaster tools the Google offers publishers, we're starting to see tools that show a view of your entire site. all the Schema.org types that you've published. And I think as we start to talk more about graphs, that's going to become increasingly important. That each of your pages tell a little bit of a story. Your entire website can start to be thought of as a data set. Finally, Data Highlighter. So this is a tool, I think of it as a way of getting started quickly. You can go in here, annotate sections of a page, and teach Google about your website. And Google will figure out, with your help, how to turn highlighted sections of a page into the graph data model of Freebase and of Schema.org. I think at this point I'm going to pass back to Jason. There we go.
So, am I on?
Mm-hmm.
Okay. Those last couple things, the developer tools, this is, I think, this, uh-oh. Woohoo.
And you're back.
Yeah. The markup helper and data highlighter went very quickly through those. I think they're actually incredibly cool and make both learning how to do markup and just getting started experimenting with structured data incredibly easy. So I would really encourage folks who have any interest in this, and since it's sort of part of the future of the web, hope you do. You guys are next, right? Okay, so there'll be full demos, deep dive. I'm sure you probably had no idea sort of what that was from just the screenshots. But like I said, we're really trying to make this easier. I mean, we've already seen a lot of adoption of structured data given how difficult it's been historically. And I think as it gets easier, we'll see even more. And as I was alluding to before, I think it's really important because increasingly this is, becoming a core part of how we index the web, how we understand the world, and how everything relates to it. And so some of the stuff that we've been seeing so far really is kind of the beginning. It's the early days. Knowledge graph itself, I've been talking about how much it's been changing search, but that's been over just the last year. So coincidentally, today is the exact 1-year anniversary of the launch of Knowledge Graph. So it's like I said, it's been exactly 1 year. And so that's what's happened so far, but I think there's a lot of new and interesting things coming. So one, I don't know how many people caught this yesterday. There was the Smart Mail presentation. And if you think about it, we get a lot of notifications or very interesting emails that have important information about our world over email, and those tend to come from websites, from services, and those emails are often in HTML. So if you think about it, everything we've been describing with markup and Schema.org and all this stuff is a way of layering this sort of structured data on top of HTML. Works just as well on email as well, and so they've started to do that. So this was what was announced yesterday. And so some of it can be kind of like what we saw with rich snippets in search, where instead of just a text snippet, we actually saw a structured result with like stars or the time and place of an event or that sort of thing. You can do the same thing with something like a flight reservation, but even go a step further. So again, by understanding the actual real-world context of this, we can actually join it with flight status, which wasn't in the email. I just know that I have a reservation, but now I can actually even know sort of whether the flight is on time or not when I am looking back at, what gate is it at? Where is my flight? I'm getting all this information that I would need in real time as well. And this is being done with Schema.org vocabulary and the same structured markup techniques that we've been talking about for the web. So I think that's kind of cool. And it goes, as I was saying, one of the things about email is it's your stuff, it's about your world, and if we want to be the sort of Star Trek computer or that personal assistant, then you have as many questions about your world, about your flights and your reservations and all this stuff as you do about that general, world knowledge that we're talking about, like, what's in San Francisco. So that's things like, well, when is my next meeting? When is my flight leaving? Where am I going? Where is that birthday party? These kinds of questions that with this level of structured understanding of content become very answerable, so that you can actually find this stuff, that you can search for it as a question, but even do things like trigger now cards when we're talking about anticipate when this information might be useful. Okay, and then finally, and this is one that I actually personally find especially exciting, but it's also very new. It's at sort of the public proposal phase in Schema.org, but we're starting to do some things with it already, which is I've been talking a lot about things and entities and all this real world stuff. And those are the nouns in the world, right? Well, what about the verbs? What about verbs are action, they're where it's happening. And we haven't been providing vocabulary for that to date, but now we are. And so that can enable some things like making information more actionable. So when we look at that flight reservation and the flight status, actually being able to check in with a single click, or RSVP to an invitation. And we can actually start to create vocabulary, and it's basically a simple declarative API, just like HTML is simple and declarative, for these kinds of things. That there is a concept. We already had markup for an event, so saying that there is an action that you can do to an event like RSVP actually becomes a fairly simple extension or layer on top of that. One other nice thing about the actions sort of vocabulary is not only can it be used in this kind of a way to provide action buttons, but we can actually use it to describe the state of an activity in progress or even in the past, like somebody took an action, like you did RSVP, and those things can be described as well. And so I think it's this kind of stuff where you actually start to see that this is more than just simple, just connecting content to the things, but actually starts to become more of a platform, and like I said, a declarative API that you're putting into your website, but in a simple and open way, just like the web is. So this is not, that then becomes available to any search engine, to any client. Okay. So hopefully gave you some sense of where things are going. And like I said, the Followup Talks are the markup tools and the help, which if you have any interest in implementing this stuff, definitely encourage. There's the Freebase talks I mentioned, and then there's also a deep dive on the email and the searchable email stuff later today as well. So with that, I'll take questions.
Right on.
And as well.
Hi. I'm currently publishing a lot of Schema.org marked up pages, about 400,000 entities that I'd like to contribute to Freebase. The problem is that it's legacy data that's kind of cruddy. So I'm wondering, I guess, two things. One, the process for actually getting our data into the knowledge graph such that we can then start pointing to it and other people can start pointing to it, I guess, via Freebase. Mm-hmm. And two, what sort of, I guess, requirements there are for the quality of the data that's coming in and whether that can be sort of accepted provisionally and then cleaned up after the fact.
So in terms of the technical specifics, definitely encourage there's like sandbox hours and office hours and can get into more detail. But I think it is worth sort of, on the quality question, that is a very big one. I mean, if you think about it, if you are trying to give unique IDs to things in the world and building up your understanding of the world by attaching more things to that, errors are a big deal. They propagate very quickly. They sort of mess up your understanding of the world. So generally, the Freebase community, and this is true with all the work we do with Knowledge Graph and Google too, think of at least 99% quality, so a very high bar. That's not just fact accuracy. In fact, the most important part is actually the identity precision, meaning that we don't have dupes and that we don't have over-clustering either, meaning that we're saying lots of things about, or we're attaching attributes of different entities to the same entity when they're actually different. It is actually a fairly high bar, but we can talk about it. We also have tools and things that we're doing to try to clean up data, because there is a lot of messy data in the world.
Thanks.
Hi, I'm wondering, is there any collaboration with the library science community? They've been studying this kind of problem for a while. And then on the other hand, like Facebook's Open Graph, and there's obviously overlap there. Just wondering.
Oh, you want to do the library science first?
That was my planned division of labor.
Yeah.
So let me talk about libraries rather than library science as such. There was a teleconference an hour ago, which is a W3C community group called BibExtend. And their mission is to extend Schema.org's coverage of books and bibliographic content. And what they're trying to do is reflect into Schema.org some of the conversations that are happening in the library world about how library catalogs evolve from kind of card catalogs to thinking about entities and relationships. So that's really our main connection there.
That's the crappy legacy data it's talking about.
We should talk. Yeah. Facebook.
Yeah, well, so there's a couple things there. One is we try to support whatever we can that's out there. So, I mean, when we talked about rich snippets, the existing microformats standards, a lot of existing standards out there are supported as part of these things. But when it came to schema.org, it was really important to have an open process that was extensible, so that groups that have real industry expertise or area of knowledge, I mean, we talk about library sciences or government data sets or these sort of thing, could actually go somewhere to approach getting vocabulary added and extended. And the schema.org model has fit that very well. That's why all the search engines are participating, and Facebook's welcome to as well.
Okay, just one more point on that, is the underlying syntax. So when they launched the Open Graph, I guess it was 3 or 4 years ago, they had to pick a syntax, and the best thing that was around at the time was RDFA1, which they sort of stretched a bit. And RDFA 1.1 was a response both to that stretching and to our choice to go with microdata. So the latest work at W3C, RDFA Lite, is very close to what we've been doing with microdata and what Facebook have been doing with their RDFA. So I think at the syntactic level, there's a convergence path that should make things lighter on your web page, even if there are 2 vocabularies there.
I mean, we do, like I said, we make our best effort to understand everything, that we can, but it's easier when people share.
Okay, my question is, what databases do you use for keeping your knowledge graph? Maybe it is Neo4j, maybe it is MySQL.
So yeah, what we use internally for representing the knowledge graph is proprietary, like most of Google's infrastructure. I guess just the scale or not proprietary, but it just was developed to deal with the scale that we're dealing with. But yeah, there are an increasing number of tools out there for graph data, as I think people are starting to realize that it has some benefits as a data model, and certainly hope to see sort of more of that the tool set for people managing graphs on their own kind of continue to develop.
In my opinion, knowledge graph, it's very interesting kind of graphs. Maybe do you have a print paper about some characteristics of this?
Yeah, there's I think there's several things. I mean, the idea of semantic graphs have been out there for a while. There's a lot of academic papers on that. There also was a Sigmod paper a few years ago on so knowledge graph started with Freebase at MetaWeb, which was a startup acquired by Google a few years ago. That's how I came to Google. Okay. And the technology that we used at Freebase, there's a technical paper, a Sigmod paper on that. It's called GraphD. It's not what we're using today, but it's interesting in terms of thinking about what does it mean from a database perspective, to have a fast queryable system for that.
You mentioned one of the points of Schema.org is to have something that's easily extensible, but what isn't very clear to me on the site is how you go about getting new data types put in, how you go about suggesting them. I mean, I work with a lot of data. I work with a lot of legal data, and most of the data does not fit in any type that you have available. I'm also very annoyed that you called schema.org/attorney a business instead of a person, because an attorney is a person, but that's...
Yeah.
A law firm is a business, an attorney is a person. But for things like case law, codes, stuff like that, they just don't fit. I mean, the closest they fit into is scholarly article, but it's not scholarly article. Right. So, I really want to try and mark it up and submit to you guys, here's all the pieces of information, let's get it out there, but...
So, to be honest, initially we hid it away a little bit because we weren't sure if we were going to be drowning in thousands of proposals from SEO advocates and so on. And we've sort of gradually made it easier to find on the Schema.org site. There's a community at W3C called the Web Schemas Group. As I said earlier, we didn't want to make a formal standards committee, but we wanted to make a place where people could come and collaborate. And there's a mailing list, public vocabs at w3.org. If you can't find that link, I'll make it bigger later today.
Okay, thank you.
But let's chat afterwards. Yes. The idea is it's
public-vocabs at w3.org is the key mailing list. That's where people have been. And generally what happens is somebody sort of makes a proposal of, we think the schema falls short, exactly like you're saying. So for this vertical, for law, it's not up to snuff. And so you can see in some areas, like in medicine, there was a major sort of proposal made, and so now it's very rich around health and medicine. We're going to need that for lots of verticals, and that's why we want to do it in this way, is because, we don't understand these verticals as well as the people who work with that data every day. And the more that these vocabularies can actually reflect the data, well, you see, we was talking about actions as one of the new things.
Kinds of crazy discussion this week. We're arguing about we're adding labor union or trade union, eventually settled on workers union, because labor is spelt two ways in different countries. And those are the kind of conversations we have. We're working to get more of the kind of corporate conversation in public too, and that's going well. You can see some of the bibliographic discussions there. What I just want to show you quickly before we're kicked out of the room, the Web Schemas group, there's a wiki. This is all under W3C. And there's a table of extension proposals. So this top table are things in progress, citations, organizational departments, which should be due this week, same as email messages, TV and radio improvements, comics, and then down at the bottom, all the things we've added. So quick answer, sling something in there, start a thread on the mailing list. The more consensus you can build, the more likely it is it'll go in. 1 minute 56.
All right, our last question.
Okay, so this is perhaps a related question, and maybe more from the knowledge graph side of things. Are there any plans to index things that are a part of our real world but less physical nature ideas, like more of the Wolfram Alpha kind of, what's gravity, things like that, maybe philosophical ideas. I know there's overlap with Wikipedia there, but...
Yeah, there's more of that stuff than you might expect already in Knowledge Graph. I think it's, we try, like everything at Google, if people are searching for it or trying to get answers around it, then it's going to be an area of focus.
Okay, Google, what is love?
That are answerable.
Thanks.
Okay. Thanks.